Welcome back. This is Lesson 3, Advanced Comparing Functions. This is actually a callback to a Unit 3 lesson where we learned how to compare functions. Here we'll be doing the same thing, but with a little bit more advanced techniques given our new knowledge of lines. All right, this lesson is best taught through examples, so let's jump right into it. In this first problem, we're told that 3 algebra classes are raising money to donate food to the local food pantry. The graphs below relate the number of days and the amount of money raised for each class. The first task is to determine the unit rate for each class. Remember, this is a simplified slope. So let's start off with fourth period. I'm going to use 0, 0, and 150 as my 2 points. So I'm going up 50 and over 1, giving us a unit rate of 50 over 1. Remember, that's $50 for 1 day, or $50 per day. Now let's do fifth period. We'll start at 0, 150, and then look at 2, 175. That means we're going up by 25 and over by 2. This gives us a slope of 25 over 2, which turns into $12.5 per day. Finally, let's do sixth period. They start at $0, and the next grid point I see is at 225. That means they're going over 2 and up 25. So this slope would be 25 over 2, which, just like the last problem, turns into $12.5 per day. The benefit of having these as a unit rate is now it's easier to compare. The next question says, will sixth period ever catch up to fifth period? Well, the fifth period unit rate or slope is the same as the sixth period unit rate or slope. If two functions are changing at the same rate, they will never intersect. They will never hit each other. If we tried stretching this line and tried stretching this line, we would see that they would always be the same distance apart and they would never intersect. Where they would intersect would be when one catches up to the other, but that's never going to happen. So I say no because they have the same slope. The next question says, which classes have the same y-intercept? And it asks, what does the y-intercept mean in the context of this problem? Well, fourth and sixth both start at 0, 0. Remember, this is the y-intercept, where the graph hits the y-axis. Remember that y-intercepts are typically talking about what happens at the start. So in this problem, the y-intercept of 0, or for fifth period 150, is talking about how much money the class has raised at the start. So we'll get that down as the meaning in context of the y-intercept. In this next example, we're going to be given 3 different representations of a function, and we're going to be asked to write the equation for each of those representations. So the first representation is a graph. What we're going to do is we're going to look for grid points. I see a couple of them. And we're going to use that to find the slope, saying that we're going down 2 and right 1. So our slope is negative 2 over 1, or negative 2. And one of those points happen to be our y-intercept at 1. So our equation is going to be negative 2x plus 1. Remember, we're used to using y equals mx plus b, but f of x is the same thing as y, so we can write it as f of x equals negative 2x plus 1. In this representation of 2 points, we're given the y-intercept right here, and then if we label these points and use the slope formula, we can calculate the slope. So let's plug those in. Remember, subtracting a negative is the same thing as addition, so we get negative 4 over negative 16, or 1/4. So our equation ends up 1/4 x plus negative 1, which is really minus 1. And we'll do a similar process here with the table. The y-intercept is what goes with x equals 0, so the y-intercept is 8. And we can use any 2 points to calculate the slope. So I'll use these 2 points and plug them in, which gives me negative 2 over 1, or negative 2, leaving us with an equation of h of x equals negative 2x plus 8. And now we have an equation for each of these 3. Next, they ask us which function has the greatest rate of change. Rate of change does not depend on positive or negative. If I was losing $100 a week, that's way more change than gaining $1 a week. So even though gaining 1 would be a larger number than negative 100, the greater change is the 100 versus the 1. So in this case, f of x and g of x both having a slope of negative 2, that's greater change than a slope of 1/4. So we're going to say f of x and h of x have the greatest rate of change because they have the largest number portion of the slope. Next we're asked which has the least y-intercept. So I'm going to focus on the constant part of each of these functions. Negative 1 is the smallest of those 3 numbers. So g of x has the least y-intercept because it has the smallest b value for all the equations. Example 3 is going to involve a lot of similar tasks to what we were just doing. We're looking at two different people's savings accounts and seeing how they change. First, we're asked to write an equation for the function g of x. Well, this function g of x, Gloria's savings, starts at 0, 300. It goes right to, and careful here, it goes up 300 because we're going from 300 to 600. So the change is 300 over 2, or 150. And as we said, the start was at 300. So our function g of x would equal 150x plus 300. Now to Ellie's savings. She starts at 1800. She goes down 900 and over 4, which if we simplify is negative 225. So with a start of 1800 and a change of negative 225, we get e of x equals negative 225x plus 1800. Now for number 3, we're asked, when does g of x equal e of x? Which x value would do this? There's a couple ways to do this problem. One would be to set 150x plus 300 equal to negative 225x plus 1800 and solve. Another option, when possible, is to copy Ellie or Gloria's graph onto the other graph to see where they intersect. I'm going to cheat a little bit and put 2 points that I see on Ellie's graph, 0, 1800, and 8, 0. I'm going to put them on Gloria's graph and then connect the dots. This gives me a pretty strong indication that the answer is at 4, 900, which we see on Ellie's graph is a known point on both graphs. So the x value of 4 makes g of x equal to e of x. This means that both functions have the same output for the input of 4. In the context of this problem, Gloria and Ellie will both have $900 in their savings accounts after 4 years. Next, we're asked, for what value of x does e of x equal 0? Remember, that's Ellie's function. Again, there's 2 ways to do this problem. One way is to plug in 0 for e of x and solve for x. Another way is to rely on the graph. E of x equals 0 means the output is 0. So which x value has a y value of 0? Well, if I scroll over here, it looks like 8. When 8 goes in, 0 goes out. This means that after 8 years, Ellie will have no more money left in her savings. The next question says, Drew starts with the same amount as Gloria, but saves more each year. Write a possible equation for Drew's savings. Well, we're going to have this again in the form of y equals mx plus b, or in this case, d of x equals mx plus b. If they have the same starting amount as Gloria, they also have $300 at the start. So we can get rid of this b and put in 300. If he's saving more than Gloria, his slope should be bigger. So if Gloria's slope was 150, maybe we could give him a slope of 200, or really any number bigger than 150. Now we have a new function, L of x, representing Logan's savings. We want to know when Logan will have the same account balance as Gloria. In other words, we're trying to figure out for which x, L of x equals g of x. Remember, g of x equals 150x plus 300. Now, typically to solve this problem, what we could do is set this equal to this. We would set L of x equal to g of x and be able to solve for x. But something I want to point out, notice that Logan's rate of change is the same as Gloria's. So they're changing at the same rate, but starting with different amounts of money. This means that they will never have the same amount of money because they're changing at the same rate, but starting with different amounts. Like we talked about earlier, this would look something like this, where the two lines would never intersect. So let's wrap up this lesson with a few tips regarding comparing functions. As far as the slope goes, the greater rate of change is the slope with the highest number portion, regardless of whether or not it's positive or negative. Regarding y-intercepts, the greatest y-intercept is the one with the largest b. It does matter if it's positive or negative when we're talking about the y-intercept. In terms of finding when two functions will be equal, which x value causes that, what we can do is we can either set the two functions equal to each other and solve for x, or we can do it by putting both functions on the same graph and seeing where the lines intersect. If you came away with anything else from this lesson, please write that down now. Otherwise, we'll see you next time.